Okay, time for our next little journey into parts C, D, and E, although D and E aren't actually labeled as D and E, but I mean, I got it. So here we go. So anyway, they have this little function here, which is negative x minus 2 squared, x plus 4. Now, when we hit graph on this thing, it's a little bit of a weird graph. I mean, there's not a lot there. It looks a little bit hard to follow, but it does appear to me that it's kind of going up in the middle and coming down on the side. So sometimes like finding an appropriate window is difficult to do. So something I showed you in class over the last little bit, sometimes it's a good idea to try something. So if I go to vars, like we did, go to y vars, remember, this thing was put into function y1 in my calculator. Sometimes it's nice to plug in a couple of numbers like, hey, what happens at 0? What happens at 5? What happens at, let's say, 9? That would give you maybe a little bit of an idea. Wow, this thing is going crazy. Now, again, I don't want these low numbers. I want the high numbers. But obviously, if I'm looking from 0 to 9, this thing isn't going very high. It's going way down to the negative. So maybe if I gave it some really obnoxious window like this, maybe I'd get a little bit of a better feel for it. So let's see. So the graph kind of comes up like that. Well, maybe I don't like that. So maybe I should go more like just 1,000 even. Maybe that's better. So it's asking me for the relative maximum on that interval. And you could see that it's right here. And there's a couple of reasons why you could know that, but an easy thing to do would be to look at that maximum number 4. And it appears that it's right in this region. So if I move my cursor to the left of the maximum over here, it's a little hard to see, but it's up there. And then move the cursor to the right of the maximum. It wouldn't be really surprising to most of us that that maximum is going to happen at the number 2, where it's going to hit 0 and it's going to have a bounce. So you can see that at 2, we have the number 0. Now, again, this is calculator speak for 2, 0. So the maximum occurs at x equals 2, but find the relative maximum is 0. 0 is the maximal value. Now, the minimum value on negative 5 to 5 is a little bit harder because what you can see, if I open my window up a little bit more, you can see that it is, oh, there's something more over here on the left side. So let's open that window up a little bit. Let's go like this, maybe from negative to positive 1,000. So again, I'm looking for the maximum on 0 to 9. It was all negative. Now I want the minimum here. Well, you can see that it's coming down and it's plummeting over here. So I already found that because it's going down. It's negative 6,561. Now, in terms of the x values that happen when this thing is positive, well, the only values that are above the axis are the numbers to the left side, which you can tell happen to the left of negative 4. So it looks like everything from negative infinity until negative 4 is going to be positive. And I didn't include negative 4 because that would be 0 itself. And then last, where is it increasing? Well, this thing is going downhill all the way to here and then uphill from here to here. So what I need to do is I need to find, I know this was the number 2, but I'm not sure about this one. So I'm going to calculate that other minimum. I'm going to go clearly to the left, clearly to the right, hit enter a second time. So it appears from approximately negative 0.4 or negative 2/5, and that, by the way, is negative 2/5 for some reasons we'll discuss later. This value is increasing on the closed interval from negative 2/5 until the number positive 2. And this has always bothered me as a student myself, that although that's the bottom of the curve and the top of the curve, based on the definition, we actually include the endpoints because the definition of an increasing function is one where no matter what 2 points you include, this one, any 2 that you want, including the endpoints, if you played connect the dots, that would be an uphill line. Okay, similar question on the next one. We're going to go in here and we're going to change our values to x minus 2, but no square on that. We've got an x plus 1 on it, and it looks like we have an x minus 4 squared. Now, again, no big shock here because we should know that at 4, it's got a 0. At negative 1, it's got a 0. And at 2, it's got a 0. Leading coefficient is positive, so it should have a bounce here at 4. It should come through like a line at 2 and back like a line at -1, according to what we studied last year. So if we're going to be finding that relative maximum on 0 to 9, you could see over here that that maximum is either going to happen somewhere in here, or most likely what actually happens at 9, because keep in mind, that thing is just going to go up, up, up like crazy. So, I mean, I could look at the picture, but I know it didn't have much time to get very high between 2 and 4, but from 4 to 9, the thing's going to go through the roof. So I'm going to ask my calculator to find the new y of 9, and that is definitely higher than that middle value we had. Now, the minimum value, on the other hand, is going to be some value in here. And actually, from 0 to 9, I'm guessing it's probably going to happen at 0, but let's see. So I'm asking from 0 to 9, and I don't think this problem is going to be quite as wild as the previous one, so I won't be quite as obnoxious on the window, but it appears that the lowest value is sitting over here on the side, because as we slide across, what you're going to see, once we get into this region, it's going down, 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 and it appears that the minimum value is going to happen all the way at the bottom of that curve, which is going to happen where x is 0, and that minimum value is -32. Now, where is x negative? Well, it'd be everywhere from 0 until the place where it crosses here, but we know that that value is the number 2. Oh, I got to be careful. It didn't specify from 0 to 9, it was the whole thing. So that would be from -1 to 2 is negative, so I need to make that rounded because it's not negative at the place where the 0 is having. And then where is the function decreasing? Well, it would definitely be going downhill from -infinity to wherever that minimum value is. And then it would also be going downhill from this value until this 4. And so I've got to be a little bit careful. Let me rewrite that underneath here because I'm going to have to find those values. But I do need to make these solid because I actually made reference to the definition before. So I'm going to go ahead and open this window up a little bit because I need to find this minimum right here, and that maximum right there. So I'm going to go ahead and let it go a little bit further back, although it's not all that important. And it doesn't look like this thing is going very low or very high in that region, so I'm going to give it a little bit more. So I think it's going downhill until it reaches 0, but we could double check. Let's calculate that minimum. Let's see if it made me a liar here. Yeah, that is 0 at -32. That's calculator speak for 0. And then I would also like to find whatever this maximum is right here. So let's look at number 4. And we will similarly pop over here and take a look at the maximum. So I'm going to go left, right twice. And that maximum, you can see that's 2.75. And I know there's a whole lot of decimals there, but that is 2 3/4. So instead of calling it 2 3/4, I'm going to call it 11/4. And so that is the region where those things happen. So that was C. Now, we actually didn't put the letters on these other ones, but this is letter D right here. And this is going to be letter E. So we've got a right triangle. So something really important about that is that it is specifically said to be a right triangle. So as we go through this thing right here, I know one side is 3x. One side, let's see, A to C is 3x. B to C is 5x. Well, you've probably seen a 3, 4, 5 a couple of times in your life. Clearly, this is playing with that 3, 4, 5 triangle. And so we have a total perimeter of 3 plus 4 is 7 plus 5 is 12x, being 84. So the value of x better be the number 7. Now, there's a couple of ways that you could have done that. It said it was a right triangle, so we could have done this and said, well, if it's 3x, we could have, let me see what I could do. Ooh, there's a lot of hard ways to do this. I don't think I want to. I guess I could call this 3x. I could call this 5x. I could call this thing 84 minus 8x, because if the whole thing is 84 and I took off these two, oh my goodness, I could call that 84 minus 8x, and I could do the Pythagorean theorem on those three things put together, but woof, that'd be gross. Much easier to realize that that's a 3, 4, 5. Okay, moving on. Now, down here, sketch the region. So we got y equals x plus 3, so it's going to be something coming up here like this. X plus 3, a nice little slope of 1, y-intercept of 3, and it's bound by x equals 3, which is a vertical line at x equals 3, which hits right up here at 3 comma 6, because if x is 3, 3 plus 3 is 6, and over here at x equals 5, 5 plus 3 is 8, so if I plugged in 5, I got 8. I have a nice little shape of a trapezoid right there. And so if I wanted to do that and found the area of that region, when you find a trapezoid, you take the two bases, which are these guys right here, 6 and 8, you divide them by 2, and then you multiply by the thickness of that trapezoid, which in this case is the number 2. As it turns out, that's pretty cool because those just canceled out anyway, and the area of that trapezoid should be the number 14. Hey, that is C, D, and E. Okay, see you back for the next one.